Hello again, Algebra 2 class. In this set of videos, we'll be looking at Chapter 5, Section 2 from your Algebra 2 textbook. That section is on multiplying and dividing rational expressions. We have three main objectives today. We want to be able to factor and simplify rational expressions, multiply and divide rational expressions, and determine the x values for which rational expressions are undefined. So first, we should talk about what a rational expression actually is. A rational expression is just a fraction where both the numerator and the denominator are polynomials. In other words, there's going to be some mixture of x's and numbers in both the top and bottom of our fraction. These are a few examples of what a rational expression would look like. Now, the first thing we want to be able to do when we look at rational expressions is determine for which values of x they are undefined. So remember that if you divide by 0, that expression you have is undefined, in any case. So for any fraction, if you divide by 0, it's undefined. This extends to rational expressions. These are undefined for x values that would make our denominator equal 0, because that's what we are dividing by. So in example A here, if we want to find the x values that make this thing undefined, we just have to take our denominator, x plus 2, and set it equal to 0. And if we solve this, we get x equals -2, which means that this is undefined at x equals -2. Or in other words, if we want to work with this rational expression, x can't be -2. Let's look at another example. This one's a little more complicated. In this case, we want to take x squared minus 5x plus 6 and set that equal to 0. Well, an easy way to solve this denominator is to factor it. In this case, it factors relatively simply because a is 1 to x minus 3 times x minus 2, because -3 times -2 is 6, and -2x plus -3x is -5x. Now remember, we're still equal to 0 here, so now we can apply the zero product property and say, well, x minus 3 equals 0. That gives me x equals 3. And x minus 2 equals 0. That gives me x equals 2, which means it is undefined at both of those places. Now, another thing we want to be able to do with rational expressions is simplify them. And fortunately, they simplify the same way that numerical fractions do. We can cancel things that divide into both the top and the bottom, or in other words, cancel common factors. So if we look at, for example, here, 25 over 30, well, we can see a common factor, right, something that divides into the top and the bottom, is 5. So if I cancel out the 5 in the top and the bottom, we end up with just 5 over 6. Simplifying rational expressions works out very similarly. We're going to just factor the top, factor the bottom, see what common factors they have, and then cancel those out. So let's look at a couple examples for that. In the top, we can see that we have, first of all, common factors with the numerical part of this. In this case, 4 divides evenly into 12 and into 20, which means we can simplify 12 over 20 into 3 over 5 if we divide both of those by 4. Now for x squared over x to the 6th, we can see that x squared goes into both of those evenly, so we can cancel out x squared, which means that all of these go away, and down here we are left, instead of x to the 6th, with x to the now only 4th power is what's left behind. Which means that this simplifies down pretty nicely into 3, that's all that's left in the top, over 5x to the 4th. Another easy way to think about canceling powers is just subtract them, and you keep that number wherever the larger exponent was. So 6 minus 2 gives us 4, and there were more in the bottom, so that's where the x to the 4th goes. Now, it's not always that easy. Sometimes we have to actually do some factoring involving quadratics, turning them into linear factors. So we're going to factor this one first. Specifically, we can see that our numerator here factors into just x and x, because that gives us x squared, and the numbers that multiply to -8 and add to +2 would be x plus 4 and x minus 2. If you distribute that back out, you'll get the same thing we started with. The bottom does not factor, it's just x minus 2. But now we can see that x minus 2 over x minus 2 cancels out, which means all we have left is x plus 4. Now, I actually skipped over the second half of these problems the first time we were running through, but there is another part of this. It asks us to identify x values for which the expression is undefined. So remember, all that means is that in the original expression, set your denominator equal to 0. So in this first part, 20x to the 6th equals 0. Well, the only way for this thing to equal 0 is if x itself is 0. Because if we divide away the 20, we just get x to the 6th equals 0. So this tells us that x equals 0. That is where this expression will be undefined. And then over in part B, if we set this denominator equals 0, if we solve this, we'll just get x equals 2. And again, we can see this expression is now undefined at x equals 2.